Hello, today we're going to look at polar coordinates. We've been looking at parametric in 9.4, and now we're going to be looking at polar coordinates, all right? So we are used to the coordinate system and where the coordinates are x and y. That's what we're used to, okay? The parametric equations that we just saw, they do use that third variable t, but the graph still end up in the form xy, right? We make the t-table, but we plot the points xy that correspond to that, okay? Because of that, the system is called the rectangular system or the Cartesian coordinate system, okay? And the system is based on straight lines, on those horizontal and vertical lines, thus a rectangle, okay? We are going to shift our thoughts a little bit and now look at polar coordinates, okay? The polar coordinate system is not based on rectangles, but based on a circle. So to form those, the polar coordinate system, we fix a point O called the pole or the origin. We fix that there, okay? So again, that's our pole or the origin. And then each point P in the plane can be assigned polar coordinates r, comma, theta, okay? R represents the directed distance from that fixed point O to the point that we're dealing with. And then theta is the directed angle. And again, always counterclockwise from that polar axis to the segment in question. Notice our polar axis is like our positive x-axis. And so to find something in the polar coordinate system, we denote that as r, which is that specific distance, comma, theta, which is that angle. Again, think about it from the positive x-axis, okay? So this diagram shows 3 points on the polar coordinate system. It's often good for us to use concentric circles. Concentric circles means they're all going to have the same center and they're just going to be larger and larger so that each of those represents a unit, okay? And then there are these radial lines through the pole. And again, this idea, this line theta equals 0, that's called our polar axis, okay? So this is that polar axis that we're dealing with. Okay. So let's look at some of these points. If we think about the concentric circles that we have here, we have here, notice a radius of 1, 2, 3. So that gives us the distance of 3. And then if we look at that theta value, like how far we would move from the polar axis to that point, that gives us a theta of pi 6. So that would be like 3, comma, pi 6. Here, notice that we are 1, 2, 3, 4 units from the center, hence the 4. And that angle theta is about 2 pi thirds. Here, we have 4 away, and we can see this is about negative pi fourths. Well, notice that there's another way for us to name that point. There are lots of ways for us to name that. But notice that, like, how would we end up with negative, all right? Now, the thing is that in rectangular coordinates, every point has a unique xy ordered pair. Like 2, 3 is 2, 3, and that's all it is, right? But in polar coordinates, each point can be represented by several different r theta ordered pairs, okay? So one example is that, like r theta and our theta plus 2 pi are going to represent the same point. Oops, sorry. Because aren't those coterminal to each other? So your theta isn't limited between 0 and 2 pi. It could be more than that, and it could also be negative, okay? So another way to obtain multiple representations of a point is to use negative values for r. Because r is a directed distance, the coordinates r theta and negative r theta plus pi represent the same point. So we said here that this point could be 1, 2, 3, 4 away, And then we can see that our theta would be this way, negative pi fourths. But let's say that we pretended to extend this out this way, and we went to an angle of 3 pi fourths instead. If we went to an angle of 3 pi fourths, to get to this point, we would have to go backwards 1, 2, 3, 4. Hence, that we could have that negative 4, 3 pi fourths. And do you guys see how those are related to each other, like the difference in the angles? Negative pi fourths and 3 pi fourths is pi. So there are lots of ways for us to graph this, to label the same point. So in this example, we're going to plot the point given in polar coordinates, and then we're going to find 3 additional polar representations of the point, but I am going to limit you guys. There are an infinite number. Let's just limit ourselves to values of theta between negative 2 pi and 2 pi, okay? And so we're going to start by plotting 2 7 pi 6. So what that means is that we're going to go 2 units out. So the first concentric circle, the second one, and then we want to go around to 7 pi 6. So here's pi, here's 1 1/6 pi. So this is going to be where we have that letter A, 2 7 pi 6. Well, let's name that in a different way. We can keep the R value the same, but instead of thinking about going a positive direction, we can think about our angle going a negative direction. So this would be the same as positive 2, negative 5 pi 6. Okay. The other thing we can do is make R negative. And when we make R negative, that means that we would be coming at it from an angle that's pi away. And so if we kind of extend it this way, we can see that this would be the angle pi 6. So we also could label, have that as negative 2 and then pi 6. Similarly, instead of talking about this as pi 6, we could think about that as a negative angle, and that would be negative 11 pi 6, because we know that those are coterminal to each other, okay? And that's kind of the idea. We'll have, when we have these limitations, we generally have 2 positive R values and 2 negative R values, 2 positive theta values, 2 negative theta values, okay? Let's do 3 2 pi thirds. And what some people like to do is some people like to start with the theta. So some people like to say, all right, I'm going to find where 2 pi thirds is, and then I'm going to go out 1, 2, 3. So you could do that. Again, or you could count out 1, 2, 3, and then spin over to where 2 pi thirds would be. Okay. So if we keep our positive, instead of positive 2 pi thirds, we could say that this is negative 4 pi thirds. And if we wanted to make our negative, we would want to use this angle. This angle could be, let's see, 1 2/3, so 5/3 pi, so 5 pi thirds. Or if we thought about that as a negative angle, that was the same as negative pi thirds. Okay. How about 1 negative 7 pi fourths? So we could go over to 1, and then we would want to go negative 7 pi fourths. So I'm going to go in this direction. So negative 1 pi, negative 1 3/4 pi. And so that gives me the 1 negative 7 pi fourths. Okay. So I could also call that 1 positive pi fourths, or I could change R to a negative value, and then instead I'd be using 5/4 pi, or if I went in the negative direction, negative 3/4 pi. Okay. All right, so again, we're always starting at this polar axis, okay, and then we're going in this direction as far as like the theta is concerned, okay? Okay, for the positive values. All right, so letter D, we have -3, -4 pi thirds, okay? So in this case, especially when it's negative, I know I sometimes like to go to the angle first and then count backwards. So if I go -1 1/3, this is where -4 pi thirds would be. But because I want to go in a negative direction, I'm going to go back this way instead. And so I'm going to have to go back 1, 2, 3 this way. Okay? And that's going to be where my point D is. Well, let me keep this negative. Okay. -4 pi thirds, again, and again, we're looking at it from here. -4 pi thirds is the same as 2 pi thirds. So if I went to 2 pi thirds, I would have to back up 3. So -3, 2 pi thirds. And then let's say I changed it to a positive R value. Then I'm going to be looking at this angle. And I can see that this angle would be 1 2/3, so 5/3 pi. Or if we backed it up, -pi thirds. Okay. If we did letter E, so -2, pi 6. So this is where my pi 6 is. So if I did -2, I would need to go 2 backwards in this direction. So this is where that letter E would be. If I wanted to keep the -R value, this pi 6 would be the same as, 11 pi 6. Or if I wanted to go in a positive direction for R, I would deal with this angle for my theta. And I can see that that would be 5 pi 6. Or if you went the other direction, -7 pi 6. Okay. That's kind of the gist of it. Maybe you've been working ahead. Here's, I'll just do one more. -4, 3 pi fourths. So here's going to be where 3 pi fourths is. I need to back up 1, 2, 3, 4. So this is going to be where my letter F is. So if I was dealing with this 3 pi fourths, 3 pi fourths would be coterminal to -5 pi fourths. And if I wanted to go in a positive direction this way, I can see that this is positive 1 3/4. So that would be 7/4 pi. Or if I'm using a negative angle, -pi fourths. Okay. And so that's the idea. That's how we can name different polar coordinates and plot them. Okay. All right. So the other thing that we're going to want to be able to do is we're going to want to be able to convert between polar and rectangular coordinates. We're going to start by going from polar to rectangular, okay? So the polar coordinates that we're dealing with are when we have the r theta, okay? That's polar. And then we're going to go to rectangular, xy. Okay, that's how we're going to start. And so how would we do something like this? Well, let's think about it. When we think about our different piece here, our specific point, xy, that's in the, we'll put this r theta that's in that polar coordinate system. We said that this is going to be r, and that this is going to be theta, and that's how we come up with that. And so really what is happening is that to get to that specific point, we want to find in rectangular coordinates, what is this x, what is this y? Well, can't we use trig to do that? When we look at that, I can see that the cosine of theta would be x over r. and that the sine of theta equals y over r. So what that means is that if I wanted to find x, I would just take r times the cosine of theta. And what do you think we would do to find y? That's right, we would take r times the sine of theta. And so that's how when we're given polar coordinates involving r and theta, we can turn them into rectangular coordinates by using this process. Okay, so this asks us to convert the polar coordinate into rectangular coordinates by hand. Okay, remember that this is r and this is theta. Okay, so if I wanted to find x, I'm going to take r, which is -4, times the cosine of theta, which is 3π4. Okay, I know that the cosine of 3π4, that's in quadrant 2, is going to be -√2 over 2. And so the two negatives will become a positive. The 4 and the 2 will cancel, and so I end up with 2√2. Okay. For my y value, I'm going to take r times the sine of theta. So -4 times the sine of 3π4. So 3π4 again is in quadrant 2, so sine is going to be positive. And so a negative times a positive will be a -2√2. So that means that the rectangular coordinates would be, would be 2√2, too many commas, sorry, will be 2√2, comma, -2√2. Okay. And if we look back on where -4 3π4 was, that was on our last page. That was over here. Okay. And so in the rectangular system, we can kind of see that this would be positive 2√2. This would be -2√2. That's really where that would end up if we were to like put that XY coordinate system on there. Okay. But that's really what we're looking for, is what our rectangular coordinate would be. Okay. So then number 8, we have 2√3 and π6. So again, for x, I'm going to take r times the cosine of theta. So r times the cosine of π6. So this is going to be 2√3. The cosine of π6 is √3 over 2. So I can see that the 2's cancel. √3 times √3 is just plain 3. And then y is going to be 2√3, our r, times the sine of theta. So that's going to be 2√3 times the sine of π6, which is 1/2. My 2's cancel, and I end up with √3. So my ordered pair in the rectangular coordinate system would be 3√3. One more like this, number 9. 28 -2π/3. For my x, I'm going to take r times the cosine of theta. So the cosine of -2π3, so that's going to end up in quadrant 3. So that's going to be negative. And so that'll be -1/2. So that'll be -14. And then the y coordinate will be 28, our r value, times the sine of theta. So again, that's going to be in quadrant 3. And so that's going to be -√3 over 2. And if we cancel, that ends up being -14√3. So then my ordered pair is -14 and then -14√3. Okay. So I think it's not too bad if you know your unit circle to do that by hand. Just for kicks, I'll let you know that the TI-84 is capable of making the conversions, although I believe it is much more cumbersome. The commands are located in that angle menu. The angle menu is over here above the apps key, so you'd have to hit second apps to get to the angle menu. So to convert the polar form, we did this in example 7, to convert this polar form to rectangular form, what we would do is we go P and then we go to RX. So we would have to go to second apps to get to angle. And then do you see how 7 is like polar to rectangular? And so number 7 is saying, do the polar to rectangular for the X, okay? And so I'm gonna go down to that number 7. And then in there, I'm going to put in the R theta type of a thing. So I'm gonna put -4, 3 pi fourths in there. So you have to put in like your R and your theta. So I could do -4, and then the comma, you guys, is above the 7. So comma, and then 3 pi fourths. Now before I press enter, I'm gonna make sure I'm in radian mode, okay? And then if I press enter, it'll give us about what that value is, okay? So that's going to give me about 2.828. And then for the Y, you would go back to second angle, well, second apps to get to angle. And now you would do number 8. You're saying, I want to do polar to rectangular, but do the Y coordinate for me. And so again, you would type in the R and the theta value. And then it would give you the approximate Y coordinate, okay? The one thing about the calculator though is that this isn't exact, right? When we did it by hand, we were able to have exact values. Remember how up here we ended up with 2√2? So that's really what that value is. You can see that it is much better to do by hand, okay? Again, the commands find the value of X and the value of Y separately, and we use R and theta each time, okay? So example 10, just to give us a little practice, it says to convert -4 pi to rectangular coordinates by hand. I think it's supposed to say or using the graphing calculator. Again, I think by hand is going to be much easier. So if I were to do by hand, I'm going just to use R cosine theta, and then for Y, R sine of theta. And so I know that the cosine of pi is the cosine of pi is -1. And I know that the sine of pi is 0. So I would say that my value is going to be 4, 0, okay? In the graphing calculator, you could do second angle, number 7, -4, pi, and then you could do second angle, number 8, -4, pi. Notice that we get that, we get that same ordered pair for 0, okay? And if you think about where that's going to land, let's think about where -4 pi would be. So an angle of pi would be over here. And then since we would want to go -4, we wouldn't want to go 4 in the right. We'd want to go 4 to the left. And so that's where -4 pi would end up with in our in our polar coordinate system. That's really pretty, right? And do you guys see that that would be the same in our rectangular coordinate system without the circles as the 4, 0? So just a little bit of a connection that way, okay? So now what we're gonna do is convert rectangular coordinates into polar coordinates, all right? So let's first review what we did polar to rectangular. So polar to rectangular is when we had our theta, and then we're gonna change it to x, y. And so what we said that we would do in that case is for our x, we would take our cosine theta, and for y, we would take our sine theta, okay? But now what we want to do is we want to go from rectangular coordinates to polar coordinates. That means that we need to go from x, y to our theta. okay? So let's again think about what this is here. We said that in our polar system, in the rectangular system, that like this was going to be theta, this was going to be r, and then that's going to be our x and our y. Okay? So let's see, given x and y, what could we do to find r, and what could we do to find theta? Okay? So if I wanted to find r, do you guys see that these are related by the Pythagorean theorem? So one thing that we can say is that we can use that x squared plus y squared equals r squared. And we can use that relationship to help us find r. Now, how could we use x and y to help us find theta? Do you guys see that the tangent of theta is y over x? So that's the other thing that we're going to use, that the tangent of theta is going to be y over x. Now, one thing is that when we think about, like, if we were to use inverse tangent, especially if it's not a nice value on our, like on the unit circle that we memorized and we have to use the calculator for it, our inverse tangent in the calculator is only going to give us specific values because of the limitations of that. So make sure that we adjust the theta value for the quadrant that it's going to live in. Okay, it says quadrant. Okay, so adjust the theta value for whatever quadrant, and we'll practice that. Okay, so this asks us to convert the rectangular coordinate into two sets of polar coordinates using 0 to 2 pi. And so we're going to use this skill that we've just looked at now, and then to get the second coordinate, we'll do what we did at the very beginning. By using an r value that's negative instead, okay? All right, so let's start by finding what r is. In this case, here's our x and our y. So we could take -3 squared plus 4 squared equals r squared. We can probably tell what that's going to be. So we know that 9 plus 16 is going to be r squared. We can see that r squared is going to be 25. So we're going to use that r equals 5. Okay? So that's going to be part of the puzzle. The next thing we want to do is say that the tangent of theta equals y over x. And you know that I love me some reference angles, okay? So and I know x was negative, sorry. So when I find my reference angle, what I'm gonna do is ignore the sign, and I'm gonna take the inverse tangent just of 4/3. Or you could take the inverse tangent of 4 over -3 and then ignore the sign, okay? So my theta prime, my reference angle, is going to be 0.927, okay? Now, let me think about where that is going to land. Where is this rectangular coordinate going to land? -3, 4 is going to land here in quadrant 2. And so what that means is that reference angle, that 0.927 is here. So in order for me to get this value theta, remember what we have to do? So to find my in quadrant 2, then I'll have to take pi minus that value. So I'm going to take pi minus the 0.927, and that gives me, well, I should probably use that specific value. So I'm going to take the inverse tangent of 4/3, and I'm going to take pi minus that specific value. Okay, and that gives me about 2.214. Okay, so in quadrant 2, my theta value would be 2.214. So what that means is that my coordinate in polar coordinates would be 5, 2.214. That's one of my answers. Okay. Now it asks us to find another one, but to keep our answers between 0 and 2 pi. So what that means is that I'm going to adjust this. Instead of being a positive R value, I could also have it be a negative R value. That negative R value, again, means that I would go to this angle and then go backwards this way. And remember that the adjustment is that these are always pi apart. So all then we would have to do to this is we would just need to add pi units to that. And then we get about 5.356. And those would be the two different values. The two different ways to express that point, -3, 4, using polar coordinates where theta is between 0 and 2 pi. Let's do another one. Number 12 is 0, -3. And sometimes I don't like to do lots of work with this one. If we think about where this one lands, for example, 0, -3, you guys, is on an axis. 0, -3 is going to be right here. What do you think that means about R? R is going to be 3 units away from the origin. And then what would we use for our theta? If we use a positive angle, then our theta is going to be 3 pi over 2. So don't make it more work, you guys, than you have to. I could have 3 and then 3 pi over 2. Now, remember, now we're going to have to look at it with a negative R value. Now, in the other question, we added pi, but if we add pi, we end up with a value of theta that's more than 2 pi. So instead, we're going to think about subtracting pi, or visually in this case, you can see that we would have to go to pi over 2 in that case. Okay. In number 13, we have -3, -2. Well, maybe the first thing I want to do is find my R value. So I can see that this is going to be 9 plus 4, which is 13. So my R is going to be √13. And then the next thing I can do is take the tangent of theta equals y over x. And again, I like my reference angle. I know that if I take the inverse tangent, the negatives are going to cancel anyway, but I see that I'm going to have a theta prime of about 0.588. So let's see where this is going to land. -3, -2 is going to land here in quadrant 3. So when I think about what I would need to do, this is like that 0.588. I want to go from here to here. So what I'm going to do is I'm going to need to add pi to that specific value. And so my quadrant 3 theta value ends up being 3.730 if I'm rounding appropriately. Okay. So that's going to be one of my coordinates, R, theta, √13, and about 3.730. Well, again, we want to see what happens if we make that a negative value, R value. And so we would need to kind of back it up this way, which means, again, if I add pi, I'm more than 2 pi. So I'm going to have to subtract pi. And most of you guys can probably see I just get my reference angle again. So it would be -√13.588. Okay. If I keep going here, -1, -1, I can find my R value. -1 squared plus -1 squared equals R squared. So I can see that R squared equals 2, so R is √2. And then if I look at my tangent of theta is going to be -1 over 1, which is 1, okay? oh, sorry. So when I look at my theta prime, if I think about the value, my theta prime is going to be pi fourths. But let's look at where this lands. This is going to land in quadrant 3 at -1, 1. So again, when we know this, we can use the exact value, right? So this is on the unit circle. Make sure that you would use the exact value. That would be expected on a quiz or test, okay? And so in our quadrant 3 theta, that means that that's going to be 5 pi fourths. So one of my ordered pairs in rectangular is going to be √2, 5 pi fourths. And then I could make r negative, and then I would subtract pi in this case, and we can see that that would be at pi fourths, okay? So 15 ends up being pretty easy. We'll do that in a sec. This is another one where I think this is a really easy one to find. If we think about where -4, 0 is, we can see that r is -4 and, or sorry, r is 4. We're going in that direction. Our r is 4. We're going 4 units away, and our theta is going to be pi. So one of it is going to be 4 pi. But the other thing that we could do is go the other way. So we could have -4, and then this is going to be 0. Why wouldn't we use 2 pi and -4? Do you guys see here that it's less than 2 pi? So we wouldn't want to include 2 pi, and that's why we choose -4, 0 instead. Okay? Again, hopefully you're getting the gist, but here's one more. We have 6, -2. So first I'm going to find r. So I'm going to do x squared plus y squared equals r squared. So that's 36 plus 4 equals r squared. So r squared is 40. So r is going to be 2√10. So always simplify that, use simplified radical form. Okay. And now my tangent of theta is going to be -2/6. So what I'm going to do is I'm going to find the inverse tangent of just 2/6 to find my reference angle. And I see that my reference angle is about 0.322-ish. Okay. So what quadrant does this end up in? 6, -2 would be in quadrant 4. And so if I think about where that's going to be, this is my 0.322, I can see that I would need to take 2 pi minus that value. So I'm going to take 2 pi minus that value, and my quadrant 4 theta, which is where I want it to land, is going to be about 5.961. So therefore, one of my ordered pairs is 2√10, 5.961. And let's think about what we would need to do for the other one. I would have to go negative 2√10, and I would want to back it up pi. So I'm going to subtract a pi off of that, and then that gives me 2.820 if I'm rounding appropriately there. Okay. I'm more concerned with getting the first one than the second one as far as these go, but it's good practice as far as kind of putting it all together. And then the last thing is to convert rectangular to polar using the graphing calculator. Once again, we would go to second apps, and then we can see here that 5 and 6 say, all right, go to rectangular to polar and find me r. Go from rectangular to polar, find me theta. And so what you're going to put in each of those cases is you'll just put in the x and the y. Okay. So this is saying, all right, I have this in rectangular form, give me polar form, give me the r value. So I'm going to go second apps, and then number 5, I'm going to hit 6, oops, comma -2. and that tells me that that's going to be about 6.325-ish. And as far as the theta value goes, I do the same thing. I'm going to do second apps. Number 6 says rectangular to polar, give me theta. My my X and Y are 6 and -2. And that gives me about -0.322. Okay. And so then that point would be 6.325 and then -0.322. Now notice that this doesn't fit the stipulation above because your calculator is using that inverse tangent. And so inverse tangent, it'll always give you that value kind of like between, like the negative value, like the smallest value that you can have. But it would be equivalent to one of these. Okay, so again, those commands find the value of R and the value of theta separately using X and Y each time. All right, I wouldn't count on the calculator though. I think it's almost easier by hand, don't you think? But anyway, that's a little bit about polar coordinates. The next lesson we'll look at polar equations. All right, happy graphing.